Okay, so today we're looking at graphs of functions. The first definition you need to know is real functions. A function whose independent and dependent variables stand for only real numbers. So this is an example from driver's education. I'm guessing that a whole bunch of you took it over the summer, or took it the year before last summer. So when a driver attempts to stop a car, the distance d the vehicle travels before stopping is a function of the car's speed, x, and can be modeled by this equation. If we give the name of the function c to the function given the stopping distance, then c of x equals, and guys, there is a typo in your notes, it should be x plus x squared over 20. We have a table. If you notice, it goes, the x is your input, the speed, and your car stopping distance is the y value. So what do you notice about the higher the speed, what happens to this stopping value? Increases. It takes a longer distance to stop. So let's look at this one right here. If I did not have a table and I had a graph only, and I wanted to know what my stopping value is for a c of 60, what you would do first is go over to 60 and go up to the graph. And then go over to the left to the vertical line here, and you would make a guesstimate. That looks, in my eye, it almost looks like 250, okay? But they had more of an exact answer. So anytime you want to just check to see, like for instance, let's look at c of 50. What would the distance be for that? About 175, yeah. So if you go up here and over, and you just kind of estimate, you would get that, okay? Now, the one on the right is comparing car versus SUV. What do you notice about these two functions? The car is the blue one, the red one's the SUV. It takes longer for them to stop, right? Yep. So why do you think there's a difference between these two? Why does it take longer to stop an SUV? Yeah, it's heavier. Okay. Okay. So let's go through some definitions here. If I'm looking at domain, I'm going to move this down. A domain is a set of allowable values for the independent variable. Those are the x values, the one on the horizontal axis. Another way of thinking of it is what is possible for x in this case. The range is the same thing, but for y. What is possible for y? The dependent value. And the last one in this box is set builder notation. This bracket x, and there's a straight up and down line. You could almost think of that as a 1, but it's not. Okay, it's really like a wall. And then 0 less than or equal to x less than or equal to 40. This is how it's read. The set of all x such that, that's what that line is in English. That line means such that 0 is less than or equal to x, and x is less than or equal to 40. So this is in the language of algebra, okay? And if you were to write it in English, you would write it this way. In looking at our example up above, we got this graph. the set builder notation for the domain. So it's asking you what the possible values of x are on the left graph. Well, the smallest value is 0, and the largest value here is 70. So that's why you have x such that 0 is less than or equal to 70, or less than or equal to x, less than or equal to 70. And you would do the same thing for the y. Notice that this y here, if you estimate it, it's not going to go above, what we know from our table from above, it's 315. But if I were to eyeball that, I would say 320. So that same vein, I want you to look at the blue graph and tell me what is the domain for the SUV. What's the domain for this SUV? Yeah, the possible x values. Has it changed any from this one? No, it's still got the same x values, right? So if I were to say domain, D for domain, x such that 0 less than or equal to x less than or equal to 70 again. But the range changes, doesn't it? What's my minimum range value? 0. And what's my maximum range value here? Well, that's the x value, but my range value is my y. So if I go up here, yeah. So you're just kind of making a guess right now. So I would say maybe 480. Okay? Okay, so in math, there's many different types of numbers, and they're all categorized based on their characteristics. Okay? So starting with natural numbers. Natural numbers, and it's written like this, n equals, when you started counting, when you were like 2 or 3, what number did you start with? 1, okay? So you naturally learned natural numbers. So natural numbers are counting numbers, starting with 1. They're whole numbers, and they go on forever. A whole number is the same thing as a natural number, but there's only one difference. You have a 0 in it. So the 3 dots mean it goes on forever. An integer. What's different between an integer and a whole number? Anybody remember? And you know, this is weird. I don't know why Z is the symbol for integer, but it is. An integer is, I'm going to say dot, 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 because it can go down forever. -2, -1, 0, 1, 2, and then it goes up forever. So it's whole numbers, but they can be positive or negative, and it includes 0. Okay? We'll come back to non-integers in a minute. Let's go to rationals. Rational number is any number that can be made into a fraction. Okay, you might want to write that in English. Any number that can be in fraction form. All right, so that would be 1/2, -7/8, so on. It can be any of those. An irrational number is a number that if you put it in decimal form, it has numbers that go on forever with no pattern. Okay, so for an example, it could be pi. Remember, pi goes on forever and ever. Another example of that would be square root of 2. Okay. In reals, it just includes everything that's rational, irrational, everything above. So you could say all of the above. A non-integer here could be a repeating decimal. So it could be 3.141414, right? A repeating decimal is still rational. So notice it says it's including in rationals, okay? It could also be 3.75. Okay, anything like that. So now I want you guys to take time, take out your CAS or your TI Inspire, and I want you to do this activity. It's on page 27 of your book. If you need to grab a book, you can. If you don't have a CAS today or Inspire, then you might look at somebody that does, or take time to do this later, because you're going to need to know how to do this, okay? So if what this does is it walks you through on how to define a function, how to graph it, and then also how to trace different values in it. So if you walk through this, it helps you to learn how to do it on there, and later on you'll know how to do it, okay?